Good afternoon. This is Dr. Gopi Krishna, Associate Professor, Department of Mathematics, Marri Laxman Reddy Institute of Technology and Management, Dundigal. Today's topic is Laplace transform. The basic definition of Laplace transform: let f of t be a function of t, defined for all positive values of t. Then Laplace transform f of t is denoted by L of f of t, where L is Laplace operator, is defined by L of f of t equals to integral 0 to infinity e power minus st f of t dt. It also can be written as f bar of s, provided that all the integrals exist. Here, the parameter s is a real or complex. Conditions for Laplace transform. There are two conditions in Laplace transform. First one, the function f of t must be piecewise continuous in the interval limit 0 less than a less than or equals to t less than or equals to b. First point. Second one, the function f of t is exponential order. The function f of t must be exponential order. These two conditions are satisfied, Laplace transform is exist. Otherwise, Laplace transform does not exist. Here, exponential. What is exponential order? Exponential order, a function f of t is said to be exponential order a if limit t tends to infinity e power minus st f of t equals to a. Here, examples of exponential order. First one, the function t square or t cube is an exponential order. Second one, non-exponential order example, the function e power t cube is not an exponential order. Second definition, piecewise continuous function. A function f of t is said to be piecewise continuous over the closed interval ab if it is defined on that interval and is such that the interval can be divided into a finite number of subintervals, each of which f of t is continuous and has both left and right hand limits every n points of the subintervals. Laplace transform for standard functions. Here we can discuss a few standard functions. First one, prove that L of Laplace operator, here L is Laplace operator, L of 1 equals to 1 by s. By applying, by definition of Laplace transform, L of f of t equals to integral 0 to infinity e power minus st f of t dt. Here f of t equals to 1. Then L of 1 equals to integral 0 to infinity e power minus st 1 into dt. Now we can apply integral by standard form, integral e power ax dx equals to e power ax by a. Here similar we can apply here e power minus st by minus s. Here limiting points is 0 to infinity. We can substitute first upper interval e power minus st, t instead of infinity, total function is 0 minus, then we can substitute lower interval e power 0 by here minus s. E power 0 is always 1. So it can be written as minus of minus plus 1 by s. Therefore, L of Laplace of 1 equals to 1 by s. This one is one of the standard property. Second property, prove that Laplace of e power at equals to 1 by s minus a. By definition of Laplace transform L of f of t equals to integral 0 to infinity e power minus st f of t dt. Here f of t equals to e power at. Then L of e power at equals to integral 0 to infinity e power minus st is same f of t. Here f of t is e power at into dt. Here bases are equal, so you can add the powers. Integral 0 to infinity e power minus s minus a into t into dt. Now we can apply integration e power minus s minus a into t by minus of s minus a. Here limiting points is 0 to infinity. First we can substitute upper integral, so it will becomes to 0. Then we can substitute lower integral minus of e power 0 by minus of s minus a. So here e power 0 is always 1. Now minus of minus plus, it will becomes to 1 by s minus a. So therefore L of e power at equals to 1 by s minus a. So similarly, Laplace transform of e power minus at equals to 1 by s plus a. Next one, prove that Laplace transform of sin at. By definition of Laplace transform, L of f of t equals to integral 0 to infinity e power minus st f of t into dt, where f of t equals to sin at. Then L of sin at equals to integral 0 to infinity e power minus st sin at into dt. We know that the standard formula of integral e power ax sin bx dx equals to e power ax by a square plus b square into a sin bx minus b cos bx. Now we can apply this formula here. E power minus st by, here a is s square, A square means S square plus B square can be written as A square into, here A means minus S sin AX minus B is here A cos AX. Here limiting points are 0 to infinity equals to, here you can substitute upper limit, total function is 0 minus, then you can substitute lower limit e power 0 by s square plus a square into, here sin 0 is 0, here next you can substitute cos 0 is 1 minus a. Here e power 0 is always 1. Here minus of minus plus, it can be written as a by s square plus a square. Similarly, Laplace transform of cos at equals to s by s square plus a square. Next, linear property. The Laplace transform operator is a linear operator. First one, L of C into f of t equals to C into L of f of t. Second one, f of t and g of t are two functions. It can be written in the linear property L of f of t plus g of t equals to L of f of t plus L of g of t. Examples of linear property. First one, find Laplace transform of t square plus 1 whole square. Now we can apply Laplace transform. First we can split this function a plus b whole square formula. Here a square plus b square plus 2ab. Then Laplace transform of t square plus 1 whole square equals to Laplace transform of, here t power 4, t square whole square can be written as t power 4 plus 1 square can be written as 1 plus 2ab, 2 into t square into 1 can be written as t square. By applying linear property, each case in Laplace operator, L of t power 4 plus L of 1 plus 2 into L of t square. We know that the standard property of the Laplace transform L of t power n equals to gamma of n plus 1 by s power n plus 1, where gamma of n plus 1 equals to n factorial if n is integer, n into gamma n if n is not an integer. So we can apply this formula here, 4 factorial by n factorial. Here n is integer, 4 factorial by s power 4 plus 1 plus L of 1. Already we know that the standard property of Laplace transform L of 1 equals to 1 by s plus 2 into, here t square, L of t square, Laplace transform of t square can be written as 2 factorial by s power 2 plus 1. Now overall we can split this one, 4 factorial, overall split this can be written as 24 by 4 factorial can be written as 24 by s power 5 plus 1 by s plus 2 factorial can be written as 2 into 2, 4 by s cube. Next problem, find Laplace transform of 2 into cos 5t plus 3 into sin 4t. Now we can apply linear property here, L of 2 into cos 5t plus 3 into sin 4t equals to, here we can apply linear property. Here 2 into, here 2 is constant, 2 into L of cos 5t plus 3 into L of sin 4t. We know that the standard property of Laplace transform of cos at equals to s by s square plus a square, and also L of sin at equals to a by s square plus a square. Now we can apply these two standard properties here. 2 into cos 5t can be written as s by s square plus 5 square. Here a is 5 plus 3 into sin at equals to a by s square plus a square. Here a is 4. 4 by s square plus 4 square. Now we can simplify this one. 2s by s square plus 25 plus 12 by s square plus 16. Next, first shifting property. If L of f of t equals to f bar of s, then L of e power at f of t equals to f bar of s minus a. Similarly, if L of f of t equals to f of s, then L of e power minus at into f of t equals to f bar of s minus a. Example problem, first one, find Laplace transform of t cube into e power minus 3t. Here f of t equals to t cube. We apply Laplace operator, Laplace transform or Laplace operator. L of f of t equals to L of t cube. Already we know that the standard property of L of t power n equals to n factorial by s power n plus 1. So according to this property, it can be written as 3 factorial by s power 3 plus 1. So 3 factorial means it can be written as 6 by s power 4. By using first shifting theorem, L of e power at f of t equals to f bar of s minus a. So here L of e power minus 3t into t cube equals to, here s can be written as s plus 3. So 6 by s plus 3 whole power 4. Next problem, find the Laplace transform of e power minus t into cos 2t. Here f of t equals to cos 2t. By applying Laplace operator, L of f of t equals to L of cos 2t. We know that the standard property of L of cos at equals to s by s square plus a square. So we can apply this property in this problem. Here s by s square plus 2 square equals to s by s square plus 4. Now by using first shifting theorem, L of e power minus at f of t equals to f bar of s plus a. So then L of e power minus t cos 2t equals to, here s can be written as s plus 1. In numerator, s can be written as s plus 1 by s plus 1 whole square plus 4. We can simplify this one. S plus 1 by s square plus 2s plus 5. Therefore, L of e power minus t cos 2t equals to s plus 1 by s square plus 2s plus 5. Next problem. Find L of e power 4t into sine 2t into cos t. Here f of t equals to sine 2t into cos t. We know that the standard formula cos sine A into cos B equals to 1 by 2 into sine of A plus B plus sine of A minus B. So we can apply this formula here. Sine 2t into cos t equals to 1 by 2 into sine 2t plus t plus sine 2t minus t. So it can be written as 1 by 2 into sine 3t plus sine t. We can apply Laplace transform of this function L of sine 2t into cos t equals to 1 by 2 into L of sine 3t plus sine t. We can apply linear property here. 1 by 2 into L of sine 3t plus 1 by 2 into L of sine t. We know that the standard formula of L of sine at equals to a by s square plus a square. So we can apply this standard formula here. 1 by 2 into sine L of Laplace of sine 3t. Here 3 is a. 3 by s square plus 3 square. A square is 3 square plus 1 by 2 into 1 by s square plus 1 square. 1 by 2 into 3 by s square plus 9 plus 1 by 2 into 1 by s square plus 1. By using first shifting theorem, L of e power at f of t dt equals to f bar of s minus a. So then L of e power 4t sine 2t cos t equals to, here s can be written as s plus s minus 4. It can be written as 3 by 2 into 1 by s minus 4 whole square plus 9 plus 1 by 2 into 1 by s minus 4 whole square plus 1. Can simplify. 3 by 2 into 1 by s square plus 25 plus 8s plus 1 by 2 into 1 by s square plus 17 plus 17 minus 8s. Yes, finally, it can be written as 3 by 2 into 1 by s square plus 8s plus 25 plus 1 by 2 into 1 by s square, minus 8s s square minus 8s plus 17. Here s square minus 4 whole square can be written as s square plus 25 minus 8s, a minus b whole square. Here we are applying a square plus b square minus 2ab. Those are reference textbooks. We are following these reference textbooks. Thank you.